Welcome to the Explainer. Today, we're diving into Momentum 1 Fundamentals, a concept-first approach to Physics 0625. But listen, we're not just going to read through a textbook today. We are taking what I like to call the last samurai approach to your Cambridge exams. What does that mean? It means combining ancient warrior discipline with cutting-edge, modern exam strategy so you can literally slice through these past paper questions with absolute precision. Whether you're sitting for syllabus 0625, 0651, 0652, 5054, or even looking ahead to 9702, the core battle remains exactly the same. You need a strategy. To show you why, I want you to picture two students taking the exact same physics paper right now. Let's call them Alex and Sam. Now, Alex is the classic over-preparer. Alex overloads every single answer with raw physics facts, dumping formulas onto the page, but includes zero actual analysis. On the other hand, we've got Sam. Sam is always rushing against the clock, totally ignoring the specific command words in the question and missing the actual requirements entirely. When the results come back, their papers are just covered in red pen marks. Why? Because they lacked a clear system. Today, we're going to fix that. We're going to use the foundational topic of momentum to build a foolproof exam strategy from the ground up. Let's get right into it. So instead of just throwing dry formulas at you and asking you to blindly memorize them, which is exactly what Alex does, we are going to build your physics intuition from first principles. Think about this starter question. What physical effect, measurement, or prediction actually depends on understanding momentum before we even dare to use the word itself? This question completely flips the traditional way we learn physics. Instead of beginning with a rigid textbook definition, I want you to imagine trying to stop a runaway train versus a bicycle moving at the exact same speed. Instinctively, your brain knows the train is much, much harder to stop. But why? Because of its mass and its movement combined. That physical effect, how hard it is to stop a moving object or the sheer raw force of an impact, is exactly what we are trying to measure in the real world. If Sam got this question, Sam might just scribble "the train is heavier" and move on, completely missing the marks. If Alex got it, Alex would write down a bunch of unrelated math. But when you start your learning journey by identifying the physical reality first, momentum stops feeling like a decorative abstract idea. It becomes a totally vital tool for understanding the world around you. If you know what physical effect you are looking for, you can reason your way out of absolutely any tricky, unfamiliar exam setup they throw at you. To truly master this, and to stop losing marks like our friends Alex and Sam, we need a core framework. I call this the four-step gateway, and it perfectly aligns with the Peel framework: point, evidence, explanation, link, that top students use to structure their physics answers for maximum marks. Step 1 is to identify the quantity. That's your point. In our runaway train example, we are dealing with moving mass. Step 2 is to state the relationship. This is your evidence, where we bring in the math. Momentum equals mass times velocity, or P equals mv. Step 3 is explaining the underlying physics, which is your explanation. What is the actual cause and effect? Well, an object with more mass or more velocity requires a much larger force to stop over the exact same amount of time. And finally, step 4 is to connect it to an observation, which is your link. We observe that a heavy truck takes much longer to brake than a small car. Walking an examiner through these exact 4 steps is absolutely crucial. Top Cambridge answers don't just state isolated facts. They show a seamless blend of deep physical understanding and practical application. Now, before we continue and look at how to actually write these perfect answers out, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's talk about transformation. Moving from concrete, everyday language to abstract physics vocabulary is a vital strategy for communicating your understanding to the examiner. Let's look at how we can turn those red pen marks on Alex and Sam's papers into green check marks. If we jump straight into symbolic relationships and complex equations, it's incredibly easy to get lost in the math and forget the physical reality entirely. This is Alex's biggest flaw. So before we ever write down P equals mv, we start with the everyday reality. A heavy, fast-moving object is simply harder to stop than a light, slow one. You build the concept in your mind using that everyday logic. Only when that conceptual foundation is rock solid do you translate it into the specific, required language of physics. This is where we rewrite the answers live. Instead of Sam's rushed, "it crashes harder," we guide Sam to write, "the object has greater mass, therefore greater momentum, requiring a larger resultant force to decelerate." Boom! That is the physics success blueprint in action. This sequence ensures that when you do finally write down a symbol or an equation on your exam paper, it actually means something real and physical to you, rather than just being a memorized, meaningless string of letters. The absolutely crucial point here is that we must make physics tangible. When you encounter a graph in a momentum question, and trust me, you will, don't just see abstract lines on a piece of paper. You need to decode the command words and stress what the slope, the area under the line, the direction, and the shape actually mean. They represent real-world movement and forces. For example, the rate of change of momentum gives you the resultant force. That's a physical reality hidden inside a graph's slope. Furthermore, physics is a strict discipline of cause and effect, not a trivia game of isolated facts. Think about how a force applied over a specific amount of time, let's call that event A, causes a change in an object's velocity. That's event B, which ultimately alters its momentum, event C. When you force yourself to clearly trace this exact cause and effects chain, you completely transform your mark potential. You go from 0%, someone who is just trying to remember what a textbook vaguely said, to 100% mark potential, someone who can actively predict what will happen in a physical system and explain it perfectly to the examiner. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to it. Why does this ability to predict cause and effect actually matter? Because of its immense real-world impact. Momentum isn't just some boring chapter in your 0625 syllabus. It is the invisible hand guiding engineering, safety protocols, transport mechanics, energy systems, and even advanced medical technology. This micro-topic stretches far outside the walls of any classroom. When you are sitting in that exam hall, the examiner is actively looking to see if you grasp this reality. Let's do a quick interactive workshop right now. Challenge 1. Data scan. Imagine I'm showing you a complex data table comparing vehicle mass, crash velocity, and impact force. You have 60 seconds. What's the core trend? The core trend is that as momentum increases, the force required to stop the vehicle in the same amount of time skyrockets. You should always be able to name at least one real situation where the concept of momentum matters. Whether you are designing a crumple zone in a safer car bumper to absorb an impact slowly, or calculating precise thruster burns for a spacecraft, your ability to link the physics directly to the outcome is exactly what sets a brilliant, top-tier answer apart from an average one. Now, let's address the elephant in the room. How do students actually lose their marks? Let's break down the ultimate exam traps and the safest method to counter them. Time for challenge 2, find the flaw. Writing a correct formula like P equals mv without actually explaining what the variables represent is a classic trap. That's our guy Alex, right? Quoting a process but failing to link it to a real physical effect? Another massive trap. Throwing out an everyday example without showing why it perfectly follows the laws of physics will cost you points every single time. That's Sam's biggest mistake. The safest method, the one that counters these errors flawlessly, is heavily structured using our Peel framework. Provide the definition, state the exact relationship, explain the physics, and clearly apply it to the scenario. By keeping your answers tightly connected to this definition, relationship, explanation, application reasoning, you avoid making any wild assumptions. You show the examiner every single step of your thought process, ensuring absolutely no marks are left on the table. You are literally guiding the examiner's red pen to give you a green checkmark. To make sure all of this really sticks, let's lock in 4 quick recall prompts specifically tailored for Momentum 1. Number 1, what is the core idea? Number 2, what changes physically in the system? Number 3, what exact quantity or specific graph shows this change? And number 4, where is it used in the real world? These aren't just helpful study tips, they are powerful diagnostic tools. Now for challenge 3, speed writing. You have 30 seconds on the clock. If you can confidently answer these 4 prompts aloud, right now, without checking your notes, constructing one perfect Peel paragraph, then your foundational knowledge is totally secure. This ties perfectly into our time management matrix. You shouldn't be spending 10 minutes agonizing over a 3-mark question. By having these prompts internalized, you are perfectly positioned to tackle short answer questions and complex structured problems rapidly and accurately. This sequence ensures you haven't just memorized a static definition, but that you have deeply internalized the entire concept for structure. You're thinking like an examiner now. We've reached the final system, folks. To guarantee top marks, you need 3 rules: command word decoding, Peel framework application, and the time management matrix. I want to leave you with a final challenge to test this system. Can you apply these 4 recall prompts to a real-life collision or safety device right now? Think about a car crash, the rapid inflation of an airbag, or even just catching a fast-moving cricket ball. Run that exact scenario through the framework we just learned. What is the core idea? What physically changes during that impact? How would you graph the forces involved? And how does understanding that underlying physics ultimately save lives? Try applying this right now. When you take the time to link abstract concepts to tangible reality, the physics stops being something you merely study and becomes a powerful lens through which you understand the entire world. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Thank you for joining me for this explainer. Keep using this gateway and keep asking why things happen.